Okay, today we're going to talk about sampling. All research projects are empirical, so understanding who your respondents are is essential to coming up with meaningful conclusions. Some of these terms you might have seen before, but they are sometimes misunderstood. So today I'm going to go through each of these sampling approaches so you can have some sense of what they actually mean, and I'll also try to keep it fun, so hopefully it'll be a little more memorable this time around. As a running example, let's take a search for a COVID vaccine, since that's already on everybody's minds right now. So in a world of unlimited time and resources, we could give everybody in the world a candidate vaccine to see how well it prevents COVID. And of course, this is not a world of unlimited time and resources, so that would be logistically impossible, without accounting for the many health and safety risks, and it's just really a bad idea. So instead, we collect samples, small groups of people that hopefully represent most people. The methods by which we select these people can influence the generalizability of the samples. So these methods listed here that I'm going to go over through this presentation, their intention is to help address possible bias within the sample. For starters, there's simple random sampling. Simple random samples are the most straightforward sample there is. In this approach, participants are selected completely at random, and only those who are selected to participate are allowed to participate. If it is truly random, then the sample should be a good representation of the population, so long as the sample is large enough. Using the COVID example, the simplest random sample would be if we had a list of all living people in the world and randomly decided who would try the vaccine. A downside to this approach is that not all people are equally likely to be selected, but may be at high risk. For example, research has shown that people of racial and ethnic minorities are at higher risk for COVID, yet because of their minority status, they are less likely to be selected by chance in a simple random sample. Stratified sampling directly addresses this bias by intentionally sampling by demographic strata. The researcher might select equal numbers of white, African American, Latino, and Asian American participants at random to ensure that these different groups are equally and meaningfully represented within the sample. A similar approach is clustered sampling, wherein participants are randomly selected from known clusters. Known clusters. What does that mean? Well, an easy example, it would be multiple hospitals, which cluster groups of people together regionally. A hospital in a very densely populated area, for example, may not have as many beds available. So for the COVID example, they might have worse COVID cases. But that wouldn't mean that the candidate vaccine used at that hospital is worse. All it would mean is that there's different amounts of resources available at different hospitals. So sampling intentionally by cluster, so to say, selecting participants randomly from multiple hospitals, helps address the bias induced by differences in population density to more specifically look at how well did the vaccine work across all people. Lastly, we come to convenience sampling, which is extremely common. A convenience sample is an easy sample, without strong methodology for selecting participants. Using the COVID example, a convenience sample would be like if you put up a flyer offering free experimental COVID vaccines to anybody who wants it. Your sample would likely include a lot of health-conscious people who might already be at lower risk for COVID. And your sample probably would show that the vaccine is extremely effective when that might not be the case. While convenience samples are easiest to obtain, they run a high risk of bias because of the people who tend to respond may not represent the population very well. So what does it all mean when we put it all together? Well, in the ideal world of unlimited time and resources, it would be great to always select pristine and systematic samples. But oftentimes that is not realistic. So if you find yourself designing a new research project, think critically about what your sample is. If you do a study of medical records on Epic, for example, there probably are clusters in the data, such as where patients are treated. Additionally, some groups will likely be underrepresented, like low-income people who may not have health insurance. No sampling is ever perfect, and more important is to ask yourself, what group of people do I want to generalize to, and how well have I represented them in my sample? Executive decisions have to get made, which will certainly reduce the quality of sampling. But, be that what it may, science is all about precision of knowledge, so more important is to identify the sources of bias in the sample so that we can know with precision what conclusions can be drawn, even if sampling could be improved.